Welcome once again. Today's tutorial is about understanding slope, the slope of a line. Let's start by talking about what slope is. The slope of a line is a visual representation of a linear equation's constant rate of change. That's how much a constant rate of change means how much you change every time the same amount. You change the same amount every time. That's a constant rate of change. Slope also allows us to create a linear graph using only one point. Normally we need at least 2 points to draw a line, but if we have 1 point and the slope of a line, that's all we need to graph a line. So let's get started. What are the coordinates of this point? This point down here. Okay, so the coordinates of that point we know are at 3, 18. 18, you can clearly see 3. How did we get 3? Well, if you see, we're going up by 6 units, but that's every other space here, so we're really going up by 3. Okay, so that's how we get 318. So let's look at the other point, and that other point is located at 1590. So if we want to find the slope of this line, all we have to do is find the change of y over the change of x. That symbol is delta. Delta means change. Change of y over change of x. How do we find change? We do some subtraction. So we're subtracting the y's, 90 minus 18, divided by the x's, 15 minus 3. 90 minus 18 is 72. And remember, the y's, we're talking about the total number of bagels here. The x's, we're talking about the total number of bags, which is 15 minus 3. That's 12 bags. So 72 divided by 12 tells us that we have 6 bagels per bag. That's a constant rate of change. Every bag is going to have 6 bagels in it. 6 bagels per bag is our constant rate of change. And that is also our slope. So let's look at another example now. This is Tony's bike trip, and he's calculating Tony's average rate of speed on his bike. So we look at that first coordinate, it's located at 535. And if we look at the next coordinate, it's located at 1070. So if we want to find that slope, once again, we're going to look at the constant rate of change there, at delta y over delta x, and that means 70 minus 35 over 10 minus 5. Which is 35 is our number of miles biked, and the 5 is the number of hours biked. And 35 divided by 5 gives us 7, so it comes out to 7 miles per hour. Okay, and that's our constant rate of change. Every time we change, we go up 7 miles per hour. Now, think about that, guys. If we're going in 5 hours, we're going 35 miles. 35 divided by 5 gives us 7. In 10 hours, we're going 70. 70 divided by 10 also gives us 7. Let's see if it works here. In 15 hours, we're going 105 miles. 105 divided by 15 also gives us 7. You can see no matter which point we go to, when we take the y and divide it by the x, we're going to get that constant rate of change of 7 miles per hour. So let's talk about now how we would graph a line that includes a point at 4, 3 and has a slope of 2. Notice, guys, we only have 1 point, but we have a slope, so we can graph this line. Slope of 2 means to move up 2 and right 1. So let's start by getting point 43. Point 43 is right there. Okay, 4 to the right, 3 up. 4 to the right, 3 up. There's our point, because the first is our x, the second is our y coordinate. Okay, now we've got to do what? It says slope of 2 means move up 2 and over to the right 1, so there's our point. Let's do it again. Up 2 over 1, our point should be right there. There it is. Now, if we want to go in the opposite direction, guys, just to go backwards a little, get some really good points so we can get this line really strong, we can go down 2, but then we have to go back to the left 1. Okay, and you can see that would stay it. So if we start from here, what are we doing? 2 up, 1 over, 2 up, 1 over, 2 up, 1 over. If we go backwards, we're going down 2, 1 over the opposite way, down 2, 1 over the opposite way, down 2, 1 over the opposite way. So you can clearly see there's a constant rate of change. We're always changing from one point to the next by the same amount, and that's what slope does. Now we have all these points, we can clearly graph it with a line. So that's our line, and that line has a slope of 2. No matter where we start, look, if we look at this point, how do we get to the next point? Up 2 over 1. So there's a constant rate of change, guys, or slope of 2. Let's look at another one. Graph a line that includes a point of negative 7, 7 and has a slope of negative 3/4. So we're going to start by finding that point 7, 7, negative 7, 7, and there's our point right there, negative 7, 7. The slope of negative 3/4 means to move down 3 and to the right 4. So 1, 2, 3 down, 1, 2, 3, 4 over, and there we go. Okay, 1, 2, 3 down, 1, 2, 3, 4 over. It should be right there. Let's do one more. 1, 2, 3 down, 1, 2, 3, 4 over. It should be right there. And 1, 2, 3, 1, 2, 3, 4. Beautiful. So what can we do now? We can finish it up by putting our line in. That line has a slope of negative 3/4. So you can see, guys, all you need is a point and a slope, and you can graph any linear equation. Pretty cool. Talk to you soon. Bye.